Hello and welcome to this NASA Goddard Google Plus Hangout, all about the next Mars mission. It's called Maven. I'm joining you here at NASA Goddard, and we have a variety of scientists who are joining us from around the country as they travel to the launch site of Maven. It's going to be launching from Florida on Monday out of Cape Canaveral. Joining us for this Hangout is Jim Morrissey. He's the Instrument System Manager for NASA Goddard. Mehdi Benna. He's the instrument scientist for the Neutral Gas and Ion Mass Spectrometer at NASA Goddard. Mehdi will be joining us in just a few minutes. Dave Brain, he's the Maven co-investigator for the Laboratory of Atmospheric and Space Physics out at the University of Colorado in Boulder. And Jasper, he is the instrument leader for the Solar Wind Ion Analyzer at the University of California in Berkeley. I'm Aries Keck here at NASA Goddard, and we're going to be answering your questions. Please either put them in the YouTube chat box, put them here in Google+. Go ahead on Twitter using the hashtag Maven, and we'll be tracking them as we go along. And you can also ask us questions on Facebook. We have a variety of people watching all these different channels for this. We're going to go right to one of the very first questions, probably the very first most obvious question for this. And that is, what is Maven and what does Maven stand for? As we see if we can lock in Dave Brain, I'm going to go ahead and put Jim Morrissey on the spot and have Jim tell us about Maven.
Hi, Aries. Maven is it's Goddard's first planetary mission. We're going to be launching on Monday, November 18th. This is a Mars mission to go and study the upper atmosphere at Mars. I can see now we have we have several of our key instrumenters on, and these guys are ready to answer questions about their instruments.
Thank you so much. And I see now that we have Mehdi Benna has joined us and Dave Brain. I'm wondering, Dave, can you let us know a little bit more about what Maven stands for, about the mission itself? And I want to remind all of our participants, if you're not speaking, put your microphone on mute. So Dave, can you hear us? How about Mehdi? Can you hear us?
Well, Aries, I can go ahead and answer the question.
Thank you so much.
Maven stands for the Mars Atmosphere and Volatile Evolution Mission. The purpose of the mission is to orbit Mars in a highly eccentric orbit, where we'll be studying the composition of the atmosphere, taking measurements, in situ measurements of the atmosphere near the surface, and then during the times when we're higher above the planet at our apoapse point, we'll be taking images of the planet, spectral images to determine the composition of the atmosphere. At the same time, we measure the solar energy coming from the sun in order to understand how that energy affects the composition of the atmosphere. And ultimately, all this information that we collect goes into models that can models of the atmosphere that we can run forwards or backwards to understand what the atmosphere used to look like hundreds of millions of years ago and what it's going to look like in the future. And one of the interesting things about that is that other missions have shown, surface missions and missions that have gone out and photographed the planet have shown that there is evidence that there was flowing water on the surface of Mars at one point, which is a precursor to life. So we need to what Maven will do is help us understand the habitability of Mars in the past, and was it once capable of supporting life.
Wonderful, and I would love to see Mehdi, now that we've got you back in the Hangout. Can you talk a little bit about the instrument that you have helped design for Maven and why that instrument ends up telling us all kinds of solutions or answers about the Martian atmosphere?
Thank you, Aries. So the instrument we have designed at NASA Goddard is the Neutral Gas and Ion Mass Spectrometer. It's an instrument that allows us to measure the composition and isotopes of neutral gases and ions of the upper atmosphere of Mars. This instrument basically look at neutral particles and turn them into charged particles by bombarding them by electrons, and then we take them through a mass analyzer that allow us to not only separate the species per their mass or their weight, how heavy they are, but also to look how many of them we have in that gas. So this instrument is key for Maven because this is the only instrument on board that allow us to see to analyze the neutral gas in situ. We have another instrument, it's the ultraviolet spectrometer, that allow us to look at the same gas but by remote sensing. So using both of the two instruments, we can actually analyze what's local and also look ahead of the spacecraft and analyze the gas at distance.
Mehdi, thank you so much. Jasper, I wanted to ask you to talk a little bit about what your instrument on Maven is going to do once it goes into orbit around Mars.
Yeah, I'd love to. So my instrument is the solar wind ion analyzer. It's a very descriptively named instrument because it measures solar wind ions. What are those? They're basically this beam of very, very fast protons, fully ionized hydrogen that's coming out of the sun at 400 kilometers per second. To put that into units that might mean a little bit more to you, that's about 1,000,000 miles an hour. So my instrument is tailored to measure that. The instruments on the Maven payload kind of fall into 2 or 3 different categories depending on how you like to think about it. There's the instruments like Mehdi's instrument that he just described that measure what's going on right in the atmosphere of Mars. Then there are instruments which measure what's coming at Mars from the sun, and my instrument falls into that camp. And then there's a third set of instruments which measures things which are escaping from the atmosphere of Mars. And of course, that's the ultimate goal of the Maven mission, is to understand how those escaping things from the atmosphere relate to what's coming at Mars from the sun. So that's kind of it in a nutshell.
Excellent. And now, when it comes to the total number of instruments on Maven itself, I was wondering, Mehdi, can you describe a little bit more about how many of them there are and how they all may work together? Oh, and quick reminder, Mehdi, you may have muted your microphone.
Yes, I'm sorry. So it really depends how you look at it. We actually have 4 packages on board. We have the plasma package that allows to plasma and fields package that's composed of multiple sensors that allows to look at the charged particles, look at the magnetic field, and Jasper talked a little bit about that. We have the ultraviolet spectrometer that allows to do a remote sensing, and we have the neutral gas and ion mass spectrometer, which is a separate instrument by itself that allow us to do in situ. So actually, they're the 3 big packages. When you count the number of sensors, my colleagues may correct me, but I think we have about 8 or 9 sensors on board.
Okay, thank you so much, Mehdi. I'm wondering, Dave, let's give it a shot. I think we've had Dave go popping in and out of this Hangout as we've been going along. This is part of the charm of using a Google Plus Hangout, is that we've got these scientists in their offices while they're getting ready for launch. So we have them in all kinds of locations on all kinds of different Wi-Fi networks. But let's see if this works with Dave Brain. Dave, tell us a little bit about the orbit of Maven and when it actually will arrive at Mars. We've already said that it's going to launch this Monday, knockwood, from Cape Canaveral in Florida. How long will it take Maven to make it to the red planet, and what kind of orbit will it have when it gets there? And that was for Dave Brain. We may still have him being held up there. Dave, is that working? How about Jim Morrissey? Would you mind going ahead and jumping on that question?
Sure, Aries. We're launching on Monday. It takes us about 10 months to get there, so we launch on Monday. We'll be arriving in September of 2004. After we get there, we perform a Mars insertion maneuver, which decelerates us, so we're captured into Mars orbit. We're captured into an elliptical orbit that we afterwards trim down to the orbit that we want. Our mission will last for, our nominal mission is for 1 year. We have the capability to extend that to up to about 2 more years if needed. After that 2-year period, we transition into a relay mode where we have a Electra transmitter on board, which is a UHF transmitter that's capable of communicating with the rovers on the ground. So, after our primary mission, we will serve as a relay for those rovers and future Mars rovers that need to communicate through us back to Earth.
Thank you so much, Jim. We have a question that's coming now on Google+, and I want to remind everybody that we're having a little technical issues with some of the participants dropping in and out during this Hangout. It's because we're reaching all these scientists as they travel to get ready for the launch of Maven, which is going to be this coming Monday, or it's expected to be this Monday. We do have a question from Google+. You can ask questions on Twitter using the hashtag Maven, in the YouTube Google Hangouts comments box, or on Google+. And I'm going to look over somebody's shoulder here. On Google+, Anders Harndal, sorry if I butchered your last name, he asked, to what extent would Mars's strong local magnetic fields offer protection from solar and cosmic radiation? Mehdi, would you mind commenting on that? How are Mars's strong local magnetic fields in any way protecting that planet from both solar and cosmic radiation?
Yeah, so Mars is a really peculiar of the 4 planets close to the sun. Mars has what we call a remnant magnetic field. So it used to have a magnetic field like Earth, and it lost it somehow. And what we see today is a remnant of a magnetic field. So the magnetic field, while it's still strong to shield the planet from some of the solar wind and the cosmic radiations, it's actually not efficient enough to ultimately shield the planet and avoid its loss of atmosphere. So, and that's where the Maven mission comes to play, because we will be looking at the magnetic field, measuring the local magnetic field of the planet, but also looking how charged particles coming from the sun interact with this magnetic field, what gets lost, and how the energy is transferred between the two.
And Mehdi, can you compare what Mars's magnetic field is like now versus what Earth's is like? It's kind of common knowledge here at NASA, but probably not common knowledge everywhere, that Earth has a real strong magnetic field that manages to protect our planet in some ways.
Yes, so the core of the Earth has a dynamo that basically is a big magnet, and that maintains a strong magnetic field around Earth. We think Mars used to have the same structure around it, same magnetic field structure, and lost it with time. So what we see today is just that magnetic remnant field that's still embedded in the rocks, and they still have that little magnetic field left, and shield the planet on some of its surface from the solar wind. If we have to compare, I'll let maybe Jasper give you an accurate number, but there is a factor of 1,000 smaller field than on what we see on Earth.
Thank you so much, Mehdi. And we have a bunch of questions coming in now on Twitter. If you're asking questions on Twitter, please use the hashtag Maven. It's hashtag MAVEN. And William Baum asks a question that we sort of may have answered a little bit, but I'd like to throw it to Jim Morrissey to see if he can expand on this a little bit. William's question is, what kind of extended science missions will Maven perform while serving as the relay? Now, I think William asked that question before we went into exactly what Maven's going to be tracking, but I'd love to see, Jim, if you could talk a little bit more about how long each one of those instruments are expected to run once Maven is in orbit around Mars.
Sure. Well, the extended mission, the first part of our extended mission would be just a continuation of what we're doing over the first year. In that configuration, we did down. Well, our periapsis is about 150 kilometers above the surface of the planet, and at that even at that altitude, the small atmosphere that Mars has perturbates our orbit to some extent. So we have to perform trim maneuvers to maintain our orbit. So what we do when we get into the relay mode is that we raise that periapse altitude to a point where we can continue on indefinitely doing operations. But one of the drawbacks of that is that we no longer are able to take those in situ measurements that Mehdi talked about close down into the atmosphere. But that doesn't mean we can't do any science. We could still take solar measurements. We could still do some of the remote sensing, imaging with our ultraviolet spectrometer. But mostly during that post science part of our mission, we will be there serving as a relay. But there is possibility to do science during that time as well.
And Jasper, you had something to add to that.
Oh yeah, just to follow up on the question about the crustal magnetic fields and their strength, I wanted to point out that actually those fields are quite strong in very localized regions. They just don't happen to be nearly as widespread as the Earth's field. So in the Earth's field right now, most of us are sitting in around 50,000 nanoteslas or so, to use canonical units. There actually are fields on the surface of Mars that probably reach up into the tens of thousands of nanotesla, but they just aren't very widespread. They only extend for 1,000 kilometers or so. So when you look at Mars from a distance, it's effectively unmagnetized. But then when you get up very, very close in one of these magnetic regions, the fields could actually be quite strong there. And as these fields rotate around, of course, Mars is presenting a different face to the solar wind and to the sun at all times. You can imagine that there will be some very dynamic effects as these strong localized field regions rotate around and present different faces to the sun.
And we have a number of videos and animations that we're going to be able to show. If you go to nasa.gov/Maven, you'll see many of these animations, a few of them that explains what Jasper was doing with his hands just there, which is how the solar wings whack and the magnetic field help complete cover Mars. We've got a bunch of questions that bring up probably something that must drive you all a little crazy, and that a lot of people are asking all about this new rover that we're putting up on Mars called Maven. And I'm wondering, Jim, can you talk a little bit about that, underscore that Maven is not a rover, but instead will orbit the red planet. But then exactly, you talked a little bit how it's going to serve as a relay, but is Curiosity going to be able to lean its head back and see Maven once it gets into orbit around Mars?
Well, that's a good question. Yeah, and you're correct. Maven is not a rover. Maven is a satellite. It will be orbiting the planet. Just to go back just a little bit on definitions, I was referring to the periapse and the apoapse, and just so everyone knows, the periapse is the periapse is the point in the orbit where the spacecraft is at its lowest altitude relative to the surface of the planet. And the apoapse is the opposite. That's where we're furthest away from the planet. But just getting back to the question, the spacecraft in its orbit will actually be too small for Curiosity to actually take an image from the surface of the planet. But we do, we will have this capability of communicating with Curiosity if we need to. And any information that Curiosity sends to us, we sort of relay directly back to Earth. So that's one of our secondary functions of this mission.
Thank you so much, Jim. Just to remind everyone, I'm Aries Keck here at NASA Goddard, and this is a Google Plus live hangout about the Maven mission to Mars. It's scheduled to launch this coming Monday. If you're watching this hangout as it's archived, continue to ask us questions using the hashtag Maven on Twitter, or at any of the NASA channels or the Maven missions. If you're watching it live now, go ahead and ask some questions on YouTube or in Google+, or again using the hashtag Maven. Many of the scientists joining us are traveling for the launch on Monday, which is why we have some interesting Wi-Fi issues and things happening. But we do have Mehdi Bena here, and he not only worked with the Maven mission, but helped work with the Mars Science Laboratory, the MSL, that is up on Curiosity. Mehdi, can you talk a little bit about that and about how the Maven science works together?
Yeah, so currently the Curiosity rover on the surface of Mars is doing an amazing work on analyzing rocks, but a lot of people don't know that MSL, the Curiosity rover, also regularly perform analysis on the atmosphere of Mars. So we have the rover looking at the composition of the lower atmosphere locally at on the surface of Mars, and we will have Maven flying over and analyzing the upper atmosphere of Mars. So it allows us actually to do great science where we can constrain the processes that affect in the atmosphere, not only by looking at the upper atmosphere, but also looking at what's happening at the surface. And when you merge the two data sets from both missions together, you can really put a very nice story of how the atmosphere evolves over geological times and how the atmosphere escaped and got lost to space for the last few billion years.
Thank you so much. We've got a question coming in from Google+, and it comes from James Lundbad. And James wants to know, how do you learn to design a spacecraft instrument? And are there graduate courses in space physics instrument design? I'm going to throw that over to Jasper to take that one. Because if someone's watching this and what they really want to do is learn how to design a spacecraft instrument, where do they go? How do they sign up to get those classes? What's your first step?
Well, that's a fantastic question, and it's particularly apt for me because I think I'm the youngest and most inexperienced instrument lead on Maven. So I learned a lot actually in the course of this project, kind of the school of hard knocks. My background personally, I was a graduate student in the physics department here at UC Berkeley, and then I started doing research here at the Space Sciences Lab at UC Berkeley, which is one of the small handful of institutions across the country that has the capability to build these things. And I think that's really ultimately the answer, is that you have to go to a place that has the capability and the experience to have done these kind of instruments and spacecraft missions before, because there's just really a lot of accumulated knowledge and best practices and engineering, not trade secrets necessarily, but lore that's passed down from generation to generation of engineers and scientists that goes into designing these things, and knowing how to build something that will actually survive the rigors of space, where it can be 50 degrees below zero to 50 degrees above zero in the blink of an eye, where it's a hard vacuum. Building things that survive these things it takes quite a lot of effort.
Thanks so much, Jasper. Reminding everybody, please keep your questions coming in. Use the hashtag Maven or write it in the Google+ Hangout. We're talking about NASA's next mission to Mars. And we have a question here on Twitter from, forgive me if I mispronounced your name, Alazar Tamrat. And the question is, why did you choose an eccentric orbit for the spacecraft? Jim, could you comment a little bit on why Maven has the orbit it does?
Sure. The idea is that, well, for one thing, with the orbit that we have, because the surface of the planet, or the planet is not a perfect sphere, the eccentric orbit that we have will move around, will rotate around the planet. So when we're at our lower, and the other reason we have it is because at lower altitudes, we are able to take the in-situ measurements, and then we get higher up in altitude, and we're able to look down and see the entire planet from afar and take ultraviolet spectral images of the planet. And with the rotation of the orbit and the motion of the orbit around the planet, we're able to do this across almost the entire surface of the planet. So we're able to get a really good sample of measurements throughout at a wide range of longitudes and latitudes over the planet. That's why we chose the orbit that we chose.
Thanks so much, Jim. Mehdi, I was wondering if you could talk a little bit more about the big question that everybody wants to know is there life, or was there life on Mars? What's the exact current state of science of what we know of if there has been any kind of live organism on Mars?
Well, it's really a quite complicated question to answer. NASA been and the international scientific community been trying to answer this question for the last, I would say, at least 50 years. And we found out that the best way to answer this question is not actually to go and look for life. But actually to go and look for precursors of life, things that makes life possible, what we call makes the planet habitable. And that's what NASA has been doing with all the missions since the Mars, initially the Viking missions in the 1970s, the Mars Pathfinder mission, and then coming up to MSL. And that's what we're trying to do with Maven and the 2020 rover. It's actually not try to directly tackle the question of is there actually life on Mars, but actually look at what makes life thrive are there building blocks on the surface and the atmosphere that allows life to emerge, or that allowed life to emerge many billion years ago? So it's really hard to tell directly and answer the question whether there is today life on Mars. But what we know today from the latest MSL measurements is that there are building blocks, there are chemicals on the surface that actually allow life to exist. There are other missions like the European mission Mars Express, and been looking for methane. This is another way to look for signs of present or past life, but we really have not designed actually a mission that goes directly and target and try to find either living or remaining remains of past life on Mars. It's really, really hard to do, and the best way is just to look for these habitable conditions.
Thank you so much, Mehdi. I just want to remind everybody that was Mehdi Benna. He is the instrument scientist for the Neutral Gas and Ion Mass Spectrometer. He's usually here at NASA Goddard, but he's on travel for the hopeful launch of Maven this coming Monday from Cape Canaveral. Also joining us for this NASA Hangout is Jim Morrissey. He's the instrument system manager. He's also based usually here at NASA Goddard. And then we also have Jasper Halakis. He is the instrument leader for the Solar Wind Ion Analyzer, and he's joining us from the University of California out at Berkeley. I'm Aries Keck here at NASA Goddard, and if you have questions for any of these scientists about the upcoming Maven mission, go ahead and give us a ring. We do have a few questions that have come through on YouTube. I'm going to summarize them all into one question. There's questions like, can we live stream it? Who's tweeting from the mission? All that stuff. I'm wondering, and I'm going to throw this question to Jim Morrissey. When it comes to getting the data in, is the data publicly available? Can people dial in and see what Maven has been sending us? Are they going to have any kind of visuals? I know a lot of people like myself sat up really late that night to see Curiosity's very first an open channel of what it's going to send back that people can see.
Yeah, that's a good question. One of the things about Maven is that we don't actually take any photographs, because that doesn't. We decided we didn't really need any photographs, and all the great photographs from the Mars Reconnaissance Orbiter and Odyssey and other and previous missions are out there, and we decided not to go there. What we're doing is the science. So the instruments that we have take science data, and the data doesn't always lend itself to a lot of visuals. But that being said, as things occur, and I'm going to throw this back to Mehdi and Jasper, because they can talk more about this. But there is a process where the information that we take is disseminated out into the community so that people can see it. And then there's also the NASA websites will continue to update people on the progress of the mission. But why don't I have those guys answer that a little bit more too?
That sounds great. Jasper, take it away when it comes to what's going to come down for the data for the instrument that you are involved in, and how people or how other scientists are going to be able to access that and use it.
Yeah, definitely. Let me break it down into a few portions, because of course it takes us a while to actually get to Mars. we turn on the instruments very shortly after we launch. Within a couple of weeks after we launch, we turn on the instruments and we check them out and make sure that everything is working in the real environment of space, which we've tried to simulate on Earth as well as we can, but which of course we can never simulate perfectly. So that's going to be a really exciting time, turning on the instruments and making sure that they work. Most of the instruments, however, are not going to be operating full-time throughout cruise, or at least not in their real Mars mode. Some instruments are on booms that are still stowed. Other instruments don't want to put all those operating hours on their instruments during cruise. I fall into the latter camp. I want to make sure that my detectors are nice and pristine by the time I actually get to Mars. So most of the instruments are not really going to be in full operating mode until we get to Mars. Also, there's going to be unique things about the Mars environment that we're going to have to learn once we get there. So when we actually get into Mars orbit, there's going to be a very intense period of checking out the instruments, making sure that they're very well calibrated, making sure that we understand all the science data that we're looking at before we consider releasing anything to the public. So I think the soonest that you're going to see a large amount of data released to the public is not until after we actually get to Mars, and probably not for at least a month or two after we get to Mars, until we're really sure that we understand what we're doing with these instruments. After that time, we're going to be releasing data to the public absolutely as fast as we can. We're contractually required to get it out within 6 months of getting to Mars, but we certainly would like to get it out even faster than that if we can get everything really understood more quickly. And all of the data is going to be available to the public. It'll all be on the planetary data system. And we absolutely hope that the whole scientific community is going to look at this data set, because our experience with these space missions is that the volume of data that you get back is such that you just can't have too many people working on it and applying fresh insights to the data.
Thanks so much, Jasper. We have a question that has come in. Looks like it's from YouTube. A question from YouTube that asked about those small magnetic fields that are currently on Mars. The person who asked wanted to know if you could build a station on the planet Mars within that small magnetic field. Would it protect a space station? Could you use those little umbrella areas that we surmise are coming out from Mars when it comes to its magnetic field, and use that to build human settlements that would be protected by that magnetic field, kind of in the same way how the entire Earth is protected by a magnetic field here? Jasper, I don't know if you can answer that. I know it's asking to take a lot of scientific leaps there about putting humans on Mars, building stuff on Mars, about magnetic fields, so take it away.
Sure, absolutely. The answer is that those magnetic fields are not quite strong enough to really build a base under and consider yourself really protected from a lot of radiation. The radiation that's really damaging to humans is actually at a very high energy. It's up in the many mega electron volts or giga electron volts, to use the technical units. Never mind about how big that really is. It's really big. It's big enough that it's hard to deflect those particles with a magnetic field. Now, all that being said, Mars actually has a pretty decent atmosphere. We don't think of Mars as having much of an atmosphere, but it does have enough of an atmosphere to provide some shielding against the nasty radiation that's out there. So I wouldn't completely discount building a base on Mars because of issues with radiation, but I don't think you would gain a whole lot by being in these little magnetic regions.
Thank you so much for that, Jasper. Thanks so much for everyone watching as well. Keep those questions coming in, both using the hashtag on Twitter with Maven and then also in Google+. James Lundblad on Google+ has what he calls another geek question. He says, what do you use to control your instrument? Is it a microcontroller? Is it FP gas? I'm going to add my own less geeky question to that. Is it a joystick? Is it a computer? Can you do it from an iPad? Like, how do you actually control your instrument, Jasper?
Yeah, so I think what that question was referring to is an FPGA, which is basically a little processor on a chip. And the answer is yes, there are FPGAs in the instrument. There's also, for the particle and field instruments at least, there's a data processing unit that talks to all of the instruments and helps operate them and command them and process the data from them. And that actually has a little microprocessor that runs on an FPGA, but actually the software is written in C. So it's something that should be very familiar to any computer science geeks out there. And it really is, it's a little computer that talks to the spacecraft, talks to all the instruments, sends commands, gets the data back. It's not a super powerful computer, you know, it's probably not even as powerful as your laptop, but it's enough to get the job done.
Thank you so much, Jasper. And a follow-up on that for Mehdi. I'm wondering, and we've got a few people asking this as well, we know that a lot of the instruments and things that have been developed for these space missions, their design was begun years ago, and now it's launching now. I was wondering if you could talk a little bit how long it took to get the instruments to the point of launch, and then does that mean that they're launched with technology that was actually cutting edge 2 or 3 years ago, or are you able to incorporate brand new technology right before launching the instruments to Mars?
Very good question. Actually, most of the instruments we built, we built for space applications have some level of heritage to them. We don't we don't build an instrument from scratch as a concept in the 3 or 4 years that it takes to develop a mission. Actually, when the mission is proposed initially, we proposed with it an instrument package that has some level of heritage and that has some level of technology maturation in it that we can bring to bear in the actual mission we're proposing. In the case, for example, for the Ingham's instrument, the instrument has a very high heritage from past missions. We have an analog, a similar instrument that actually flying right now on Cassini, the INMS mass spectrometer. It's the grandfather of the Ingham's instrument. And then even prior to that, we have INMS have a precursor, which is the mass spectrometer that flew on a Pioneer Venus orbiter. So what we do is basically between missions is we take an instrument that worked well in space and we do little incremental advances in both the technology and the way we operate the instrument, and then we propose that for the following mission. And that allows us to have the confidence that we actually not making too big of a jumps in the technology that makes it unreliable. The level of development we do for a mission like Maven, it's actually not that big. We take the heritage sensor we have or the heritage instrument we have, and we look what the mission, the peculiar thing that the mission need, and we implement those on the new version of the instrument. But ultimately, we're not really jumping into a new development.
Thank you so much, Mehdi. I have a question it's coming for Jim. I think is ideal for Jim. And the question is, if you don't mind, again, I described that we usually have a bunch of visuals and things that we play in these Hangouts. We're having some tech issues with everybody being all over for this as everyone travels for this. So there's a lot of different animations and visuals and pictures of the spacecraft and how it gets there up at nasa.gov/Maven. Jim, for the people watching this Hangout, though, can you describe how large Maven actually is? Does it have solar wings like so many of the other orbiting spacecraft we're used to see? Does it have anything different on it? What does it sort of look like, and how big is it?
Okay, that's a great question, and I'd also encourage folks to look on the NASA site because there is a lot of good stuff on there. And then also, you can see the spacecraft displaying on the screens behind you there, Aries. So you get an idea of what the spacecraft looks like. And I'll say that when the arrays are deployed, the spacecraft from the tip of one array to the next is about the length of a school bus, of a large school, of a standard school bus that we see. The spacecraft as a whole weighs about as much as a little bit more than an SUV. So it's a large spacecraft. It's not the largest out there, but it's a pretty good size, especially once those arrays are out.
And Jim, can you tell us a little bit about, sorry, there we go, there was the reverb. Tell us a little bit about how we're getting Maven to Mars. You're saying it's the size of a small school bus. What kind of rocket is it going to be attached to? I imagine, of course, it's probably folded up in some sort of nose cone. Is that part of the 10 months it takes to get there? Does it unfurl right away, or does it unfurl while it's on its way there?
Sure. You can see, if you look at the pictures of the spacecraft there, you can see that the arrays have hinges in them. So right now, the spacecraft is here at the Kennedy Space Center. and it's folded up, and it basically looks like a box with the arrays folded up against the sides, and it is inside. Our launch vehicle is an Atlas V 401 vehicle, which folks can look up online and see pictures of. It's a two-stage rocket. It has a booster stage that gets us up into Earth orbit, and then has a second stage, which is called the Centaur, which carries the spacecraft performs a second burn to get us on a trajectory out to Mars. As soon as that burn is complete, the spacecraft separates from the vehicle and is on its own. Very quickly after that separation, however, the arrays do deploy so that we're able to get the solar energy we need to charge our batteries. And then we're in our cruise configuration and on our way to Mars on that trajectory. And then 10 months later, we're at Mars.
Thanks so much, Jim. So Mehdi, I wonder if you could talk a little bit about, we've talked about all the different instruments that are aboard Maven. What kind of power requirements do they have? Do you send them up there with giant batteries? Do you rely on the solar array keeping them charged? How do you keep them all powered up the entire time?
So all the instruments that usually are qualified to fly in space, one of the constraints we have on them is to consume the least amount of power possible. Whether the spacecraft have solar panels or use a radioisotopic generator, like the MSR rover, we still need to conserve energy. These devices don't produce an infinite amount of energy. I think for the Maven spacecraft, we have about 1,000 watt available at any time for all the instrumentation and the spacecraft itself. So we try to design these instruments with the energy consumption in mind. For example, for actually one of the most consuming instrument on the spacecraft is the ENGAM's mass spectrometer. We consume about 30 watts. That's a small light bulb in any household, and even by that measure for space application, that's a lot of power for an instrument. So we try to keep all these instruments to not consume more than a few hundreds of watts, so the spacecraft can actually, in the case of Maven, that relies on solar panels and the energy coming from the sun, that keeps the spacecraft running whether Mars was closer to the sun or a little further over the Martian year.
Thanks so much, Mehdi. I have a follow-up question to that. That's actually, I can imagine for you gentlemen, it's probably quite sad, but all spacecraft have a lifetime. And I know recently a spacecraft that orbited Earth just came down safely and did what it was supposed to do, sort of burned up mostly in the atmosphere, and then parts of it, if any, landed in the ocean. When Maven reaches the end of its hopefully incredibly long lifetime, what happens to it? Where will it go from there? Mindy, can you comment on that?
Well, unfortunately, it's true. Most of spacecrafts have a lifetime on them. At some point, the electronic component, the mechanical system will fail, and the spacecraft will cease being in operation. It depends where that spacecraft is. For a case of a rover, the rover basically will stop moving or will stop sending data. That's the case, for example, for one of the Mars exploration rovers, the rover Spirit. That's going to happen also for the MSR rover at some point after a long time and a lot of science delivered to us. It also is going to happen to Maven. So that's part of the strategy that Jim was talking about earlier. After the nominal science mission, we will be a relay. We will provide relay to the surface assets, and that allow us to actually change our orbits and not have to dip that deep in the atmosphere, which allow us to last a little longer and conserve fuel. But even with that, at some point, either the instruments will cease functioning, or the spacecraft itself will cease functioning. What will happen to it? The orbit will slowly decay, and will get lower and lower and lower. At some point, the spacecraft will start feeling the resistance of the upper atmosphere of Mars, and in one of its orbit, it will actually re-enter, will enter the atmosphere and will burn into the atmosphere of Mars.
Let's hope it does that long after it collects a tremendous amount of science data and all of your instruments work beautifully. I'd love to know, we have just a little bit longer to go. Jim, I was wondering if you could tell us two things. One, where you're going to be on Monday when hopefully Maven launches. And for you, what's going to be the first time that you stop biting your nails? Is it when you first see data? Is it when the rocket leaves the pad? Where are you going to be on Monday, and when do you actually sort of relax and start enjoying the mission?
Well, on Monday I'll be here at Kennedy in the Operations Center, watching the launch, and yeah, there'll be a little bit of biting the nails. It's an exciting thing to see the mission take off. As far as when I'll relax, well, there's a couple of times where we're going to be very busy and very focused on what we're very focused, and that's going to be at separation, when we separate the spacecraft, making sure that the spacecraft is healthy, that the propulsion system starts up correctly, that the arrays come out, and then later on while we're on our way to Mars, I'll be working with Jasper and Nettie and many others to make sure that the instruments are all operating correctly. But then the next big thing that is a very intense operation will be the Mars orbit insertion, and that's when we fire our main engine. It's our biggest maneuver, and it's the most exciting part of the mission, getting up into orbit. So it'd be that Mars orbit insertion will also be a big time, and then after that we start doing science, and hopefully all our instruments will be working properly, and that's probably when I'll relax, in about a year or so.
And for people who may have missed this a little bit earlier, how is that controlled when it is inserted into orbit? Is it something that's automatically going to happen, that Maven's going to do it on its own, or is someone here on the ground going to be like, fire the thrusters? How does that work?
Well, as we get closer to Mars, we'll have that planned, but because there's up to an 8-minute delay, there's a significant time delay in our communications because of the speed of light, and because Mars is so far away. We have to load what we do is we load in a script into the spacecraft's computer that executes all the steps and ultimately the insertion burn, and that's all done autonomously on the spacecraft. But there's also a lot of sort of fail-safe things going on at the same time to make sure that even though we're not sitting there controlling it directly, and we do have this delay in seeing how things are going, the spacecraft has some smarts, so that it knows it can do corrections, and it could if something isn't working right, it has sort of fail-safes in it that will keep the burn going and will make the burn successful.
Thanks so much, Jim. I know we have a little bit longer. I want to get to Jasper. Jasper, where are you going to be when Maven launches on Monday, hopefully? And then is it the same for you? Do you have the same sort of long delay of waiting and then years of work ahead of you?
Yeah, so where am I going to be watching the launch? That's actually a great question, and I haven't quite figured it out yet. The reason that is I'm going to have a 2-year-old with me, so I have to find some place where I can both see the launch and entertain a 2-year-old. So that's a somewhat conflicting set of requirements that I'm going to have to satisfy. And I think I have an idea of where that's going to be, but I'm not 100% sure yet. I have to negotiate with my wife and my parents and all my family that's going to be there and figure this out to the satisfaction of them and my 2-year-old. The question of when I'm going to relax, boy, I don't know, never. I mean, my answer is about the same as Jim. There's some big milestones that are going to be kind of nail biters. There's obviously launch, there's separation, there's turning on the instruments in space for the first time, there's getting into Mars orbit. But even after that, there will be a couple of events that are going to be pretty exciting. And I'm not too scared of them, but I'll probably still be biting my nails a bit. And I'll be biting my nails in particular when we do these deep dips. Our nominal orbit goes down to about 150 kilometers, but 5 times during the mission, we're going to lower that closest approach down to 110, 120 kilometers. So we can kind of do a toe dip down into the deep atmosphere and sniff it and look at what's going on there. And that's going to be a little exciting and fun to watch too. So I probably won't completely relax until we've at least done one of those.
That sounds absolutely harrowing. And so, Mehdi, last question for you. Where are you going to be on Monday? I know, but tell our viewers where you're going to be on Monday for watching the launch. And then also, at what point do you go on vacation then till the instruments kick on? And then what's the next step for you?
I will be at the Kennedy Space Center, Cape Canaveral, to watch the launch. And it's obviously the accumulation of many, many years of work. But like Jasper and Jim said, it's just the start of a long mission. So we still have a lot of milestones to meet and to successfully accomplish. Really, we're not going to be able to take vacations right away, because as soon as a few weeks after launch, we will have to start turning on the instruments, making sure that all survive the launch environment and they're good to go for a long mission. And maybe after that, we'll take a week or so.
Thank you all so much for joining us. This has been a obviously live Google Plus Hangout chat about the upcoming Mars mission Maven. If you've been watching this, thank you so much. If you're watching us in the archive version, thank you as well. And you also get all kinds of additional animations, videos, details about the mission. Up to and after Monday, if you go to www.nasa.gov/Maven, again, that's NASA's website, nasa.gov, and then go /Maven. I imagine that's going to be the top thing on the nasa.gov page as well, so you may not have to worry about negotiating around in there. And I want to thank the gentlemen for joining us, and I'm very sorry that David Brain wasn't able to stay in the Hangout. It was completely a technical issue, and we'll have some information from Dave both on the nasa.gov page and then also along in this YouTube Hangout in the comments and things like that. Dave was joining us from the Laboratory for Atmospheric and Space Physics at the University of Colorado in Boulder. And then also joining us from a university is Jasper Halakis. He's the instrument leader for the Solar Wind Ion Analyzer at the University of California in Berkeley. Thanks so much, Jasper. Also, then our 2 people from Goddard has been Mehdi Benna. He's the instrument scientist for the Neutral Gas and Ion Mass Spectrometer. And then also Jim Morrissey, the instrument system manager at NASA Goddard. Thank you so much for watching. I'm Aries Keck at NASA Goddard.
Thank you.